Okay, let's start. Secure sentence. Okay, and you given the positive figures and auxiliary graph. Those are labeled from 1 to n. You also given a 2D age. It's a bidirected no age between nodes AI and BI, and the graph may be disconnected. So divide into a group such that each node will belong to exactly one node, one group. Every pair of the group are connected in a graph at age, and this group at x, and BI's group is y, ABS distance index. Okay, so index. Okay, I first need to think what is an active one. If it's impossible group such that as given the condition. You think about example. What is the impossible? It means we have a cycle here and here, and if we have a cycle like this, they also can build as a group. But how do you this should be none. There's a cycle. Okay, for the cycle of this. That means cycle length is 5, like this. Okay, so impossible case need to think. Find the maximum group such an age group index distance is 1. Okay, that just determine the possible impossible case. It's a cycle length, it's odd. And there may be disconnected, but it doesn't matter because we don't need to care this, and we need to make sure that it's a sense that we have the cycle. We need to calculate a cycle. Okay, so This is a group. I'm thinking that. How do we know the cycle? It's odd. Need to think how to do that, but okay, skip. Let's just do from problem 1. Currently no idea problem 4. Sentence is a single space, no leading or trailing zero. Okay, sentence. Okay, words only on uppercase or lowercase. Circular, the last character equal to the first characters of the last word is equal to first. The last of last word. Okay, these two conditions. It's circular. So circular is this. The last of a word is equal to the first of the next word. The last character of a word is equal to, that means that the first and last is equal. And the last characters of the last word. Last character of the last word is equal to first character of first word. Wait. The last characters of a word is equal to first character of next word. Oh, I mean, I can got idea. So, use string to passing the sentence. Just passing the string and just compare it to the array. Right? Actually, it's a word. Word and so current word it's array 0 and the next word. +1. We need to make sure if the current, the last words of should be equal to the next. Otherwise, it's false. Okay, that's the idea. Right, so this is good and this is not good. This is good, 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 and good. Right. Okay, so what happened? Alright, so divide the player into teams of equal skill and given a positive integer, event length, and divide two teams of size 2, such that the total each team is equal. No way to divide the team scale is equal. So the chemistry total scale is equal to put out scale of the pattern. Sum of the total scale each case equal means divide pair into following teams 1, 5. Okay, sum of the total scale is equal, right? and also the product scale on the pair is 5, and okay, and sync. How do we divide to equal? That means it must be how do we match len? If we search a string, and we'll get it, that's find the product of sum of find the sum product of the team, and team or team size is 2 and sum is all the same. Okay, how do we pair? And you know the max. I'm just thinking that it's if 4 or 5. Seeing if this has actually we sort it, and the max always pick the smallest because these two value always be the greater value, and this will always be decreasing. So the make sure is that the best way is pair the first and the smallest. So that is a good approach, right? And yeah, so pair then. Let's get sum. We sort of scale and sort scale and pair then. Smallest array I, array n minus 1 minus I, because the maximum increasing, the smallest increasing and maximum should be decreasing to make the balance, So scale and we also have integer of scale size. Sum should be scale 0. Let's say answer. Divide 2. Okay, current sum is going to be scale I plus scale I. If current is not equal to sum, that means 1, and answer will add about this value. Product. Make sure that there will be, okay, it's not go before, so should be great. Alright, so that's idea and answer. Okay. About problem 3, it's 2D arrays of roads. It's a bidirectional, and the score of a pass is determining the minimal distance of a road. What it means? We have this case, and we want to find out that minimums of the CD1 to CD4, its score is minimal distance of minimal distance over the pass. Actually, just the extra, right? If they cannot be, the test case is generated at least a pass. Okay, so they never be impossible. So no idea is go find the mean score. Score is pass. Mean value of the pass. Actually, idea I think I can use the ultra. Use the ultra algorithm to find the shortest pass. So we need to build a graph, and the first it should be the pair. Build graph. Also need the row that's age and rows. Because these are connected, so there should be age 1, age 2. Underwriting graph, so we need to build a reverse, and also I should do it's a heap. It's a priority queue. Right, so define, because this looks so long. Alright, greater, because we want to find the mean heap. Okay, and the distance. Rows and anti-max. Okay, maybe I can use its maybe I can use its very big value to make sure they are great. Okay, so distance 0 is 0 because we don't have anything, and I need to do is the cost. So basically the mean heap should push back the index and the distance, right? And they are y index, so make sure that it's 0 index. So what is the distance? It's it's very big, but doesn't matter. Mean heap size, we also have the current node and the cost. And for the value, the weight in the graph, we find out that is the mean of the value cost and weight. If the mean is greater, smaller than distance u, it means they are smaller, so mean heap can push as the mean distance of this. So distance of this, where the code should be here. So it's the coast and the node. Okay. And yeah, so we updated. Actually, distance codes are too big. We don't need to optimize. I think it's good. Yeah, I've tried it. Not a pushback, sorry. That signal. So it's a close. Wait, what am I doing now? And 1 to 4 is, wait, what? The distance 2 and, okay, so, the mean distance of this should be 4. Oh, wait, it can be 2? That is interesting here. We can, the pass. Okay, so, well, we cannot do this. Yeah, it should be 2. It should be 2, and I think this is work. Okay. Dodge Argison. Yeah, actually. This problem, I currently have no idea. So missing some case in problem 3, but okay, and okay. So psychoanalysis. Is it easy to implement? Lab cycle. 1, 2. This is 1. This is 2. 1. How do we know? Kind of think. In other group, it should be from a node like this node. And this is a tree. This is a tree. Do I really need to consider the case, or I just use any node? In this graph, if we are starting from this, or we are starting from this too, let's see what happens. So let's see what happens. Okay, quick draw IO. I need this I think the same group. It doesn't matter. We don't need to care size. Not old. It's if a node come from same group, or far distance group. Okay, so some ideas use for each connected component, find the mask group. Mask group. I think we can use VFS to level order. And I think if we starting from any points, doesn't matter. So connected component part we can use union find. Okay, use union find. Okay, so yeah, actually is this. Maybe I can use union find to do that. As a parent, and we should have a find. Keep finding. Otherwise, we have union. Same group. Just random set then. Okay, so that's one index. Okay. So we need to build a graph. Age. Also, we need to union then to I just use this. Do a lot of calculation, but actually it's not. So we union length, and for each PI is 0. We do BFS. Get the label. Okay, and I'm just thinking that it's if anyone cannot be divided, it's union find. So yeah, thinking in this case. If we're starting from 1, what? Oh wait, it's not this auto draw. Yeah, it's this. Okay. So slow. Oh wait, come on. Right, I get BFS, but this session it is seeing this is correct or not. Because I want to make sure each group, if we're starting from this node as the root, what happens here? It will make should not okay. So we have 1 to 5 to 1. So 5 to 1. Okay, if we're starting from 1 and this will be a group, and the 2 and 4 also be a group. 2 and 4 also be a group. 2, 4 also be a group. Okay, and they have 6. They also have 3. They also have 3. 3 is from 2. Alright, so that's not good. Because if we are from this node, the BFS actually is a good index here. Actually, this should be a good index. So we need to think how do we do here to make sure that disconnected. I want to know disconnected answer should be wait. If they are disconnected, actually we just add them, not a find the maximum group. Find the maximum group some of them, but get a label, but here is the problem. We should start from this. If we're starting from 3, it can be the answer, right? So this guys can be 1, 2. If we're starting from 3, get this 2. And 2 will get 1 and 6. 1, 6, and 1, 6 got a 4. 1, 6 got a 4. That's 1, 6. And 1 got a 5, let's say. So, okay, I may have an idea. So we need to BFS is correct, but BFS should start from leaf node. Leaf node is in degree is 1. Degree is 1. This is leaf node. Actually, list is not a leaf node, so we are not good. So for example, we have this one. Is this a good leaf node? No, it should be good. Okay, got it. Right, thinking that. So, so I want to use its group. For each group, we are finding wait, if we don't have, say this, we're finding this, so this case, in this group, so mean degree. Also, I need an in degree here when we build. The node. Alright, so yeah, and mean degree is maybe sun, and the start node, I don't know, but maybe it's G0, no. Start is start is equal to mean degree is smaller, then means we update the mean degree, and start position may be x. Okay, so when we find x, so we can do the BFS. We do the BFS. So do BFS. Find the mean degree. Find start per. Alright, so do BFS. Just easy to do that. Start position. I need to sync. Level. I want to use a visit. Consider this case. If we have different node updated. Okay, so for graph, distance. And let's think. It's okay, distance can be wait, I also need we need the node and distance. Start 0 and the distance count and the distance v is not equal to distance u plus 1. We can divide to a good node. Otherwise, distance v is distance u plus 1. Push also need updated. Okay, that should be answers. Writing the null pointer, what? Graph. It's a good graph. Start is X. Okay, need to debug. This is good, but it's probably bad. Is this? No reference. Why? Okay, I forgot. Reiterate all. Okay, so starting from -1y. sure what happens here, but in this case, we also need a parent, right? So I also need a parent. So, wait. Because it's on the directed graph, so I also need a parent, so okay, 1. So need a parent, and what can I do the parent? Parent is you, this case. Why? Oh, wait. If not D and continue. Oh. It's weird. What happens here? Wait. Current. Let's see this node. Okay, I just think this should be from. Okay, let's think. Wait. Oh my God! So, I don't understand where is wrong. We're starting from 2 because 2. Wait, it's not mean integrate. Index is 2. Oh, it's 3. Okay, it's good. And we're starting from 2, 3. The stream is going to be 1. We may add 1 to make this easier. So, starting from 3 and the distance 0, and we're starting going to be 2. So 2 now 2 is going to be 1. And 2 is going to be 1, right? So 2 is going to be 1. So 1 is 2. And 5, 6 is also be 2. And we got a 4. 4 is going to be the... Oh, wait. It's not the... 1, 6 is 2. 1, 6 is... 1, 6... Okay, 1, 6 is 2. But 4 is... So we got... Maybe we can say that if distance u is not accounting Because seeing this example, if we have 3, then we build from this node. Starting from this node, but also have it's not previous label, so we don't need a parent, but I think we can use distance to get this is parent. So yeah, but let's see. Should be use distance to determine that. Yeah, but distance should be equal to 1. Okay, so it's a wrong approach, or there are something wrong. Distance continuum, distance is not equal to d continuum. What happened? It's group. We may have one. The same level should be the same group, so thinking that the same level should have be the group. This is weird because okay, so current level should be the distance, but add what? Missing 4, but they have been visited. Why this is wrong? For each node, in this case, no, it's not this case. So it's that should be the JSON node. That should be the JSON node. minus 1. Oh, I don't understand what happens. Maximum number of groups such as given condition. What happens here? Wow. Oh my goodness. Synchronity component, but it's just weird. I can get why it is wrong. Order. Using degree. Try to make degree. Let's start from it. Find the group. Group is empty. Continue. Calculate the answer for each group. Each group equal to exactly one group. Don't understand. What happens here? So this group is U and D. Starting from this, and if we get this, so plus 1, level we are starting from 1, and can we get an answer? No, right? Learn is 1, so only have 1 level. So let's just I'm not sure, but too weird. Okay, let's see the group. Okay, it's a large case. Oh my goodness, so it's hard to debug. Right, so missing something, but I'm not sure why I'm missing. O1. Group size of 1. So it's 1, 1, 1, 1, 1. Many 1. 2, 4. Sage size and current. For half 3 is good. And let's have 2 nodes. This makes sense. Yeah. Right, so this does not make sense. We have a lot of nodes. I think What's the error? What's the error? Okay, so if we have 5, 1, 2, 3, 4, 5. In this case, in this case it's 9. We have 9, but actually maybe it's wrong, right? So I have some cases wrong, but I don't understand why I'm wrong here. But maybe you can do at least. So this case, maybe we have this allowing degree, and maybe we have something this. And if we're starting from this, that can be small, can be small, can be small, like sure, I'll start point, right? Think. Round start point. Oh, okay, I find it. So in this case, this is 3, this is 3, but we should choose this. Oh, so it's not a mean degree. We should find its farthest node. DFS. Right, I have some idea. It's 9 degree. It's 9 degree. So starting from this node, or we say farthest node. So I should find the farthest node, right? Because the mean degree may be this point. This is 3, and this is 3. So actually starting from this, we'll get a better answer, right? If we're starting from this is the middle point. It's not a good. Okay, this is the wrong approach to find it. So this is good. So this is good, but the wrong is that the find spot point is wrong. Alright, so it's wrong, and we need to update it. Not finding degree. Let's find the DFS. Okay, so we need to find the DFS. Auto DFS and okay, and graph. Distance. Okay, and yeah. So start position. steps and the node. Need to make sure starting function is 0. Find the first node. We don't update it, but actually you don't need to initialize this. So if max steps is D, and we update the start. And V, U, and D plus 1. Okay, and yeah, this should be good. So void function y. Okay, make sure that will be updated. Oh, alright, so start positions for this node and from this node, and no, it's not a P. We are continuing it. It's the node. Say sample. Basically, we are finding the max steps in DFS. Starting from G0, it's not wrong, but why is it not wrong? We have nearest position, take plus 1. It's not a tree, it's a graph. So I'm going to use the parent. What is it? It's not a graph, so it's not a tree, so you have to close H, you cannot do that. Alright, let's work. Okay, so I have some errors here. What? Start position is not wrong. Start position is not wrong. So, why? They are starting from the next sense here. But, we start from any position. First node. In this case, if we're starting from this, I'm not sure what happened. Oh my goodness. I'm not sure what happened. The start node is equal to U. There can be it's hard. I think it's wrong, but I cannot find the good approach to find the node we start. So it's a precise and node. It's weird. This is weird. This is really, really weird. I'm not sure why my approach is wrong. Stop. Still be 9. But it's not. In this case, I think it's 1, 2, 3, 4. Okay, maybe you can use this. I may have some case. It's like this. 1, 2, 3. And we also have a node. 1, 2, 3. We also have a node. 2, 3. We also have a node. This is also BS3. But we cannot start from this node. We cannot start from this. 1, 2, 3. Not sure, but how do we find it? We find the sorry, I forgot to do it again. It's more suitable, but find the depth node and find the depth node. Maybe depth node is this one. It's 1. That's just weird. Why this is different? I don't understand why. Why the answer is different? 0 starting position, and their distance is why? Really weird. Why did I going to be 11? So if we are not doing this, it's 30. And if we are from it's weird distance. Oh wait, let me have cycle like this. We have cycle. Cycle. How to deal with cycle? Cycle case. I'm not sure what's wrong here. Cycle case. Cycle case. Put someone. It's not this small. my goodness. So, if I use there may be wait, the n is small. Wait. Can find start node by the such. Well, I may have some idea because the start node it's we can do start 0. So there are too many. So S and best and we'll start with 1. Alright, that should be a good start node. I'm not sure, but so minimum in degree. No, Fido in degree. Fido mean in degree. Okay, it's not. Alright, so it's very start position because the n is small. I just waste so much time to optimize my approach, but it actually you don't need to care because the n is very small. So yeah, so actually this group it's we may do mean in degree, and each time we traverse the group of the cognitive component. I'm not sure what its time complexity, but this will be based on this times this. So this will be E, this will be N, this will be N. So actually I think it's maybe it's OE. Okay, so time complexity, I think it's an E. Yes, I think this is. Because this can work. This can work. Find the best points failed because they have too many candidates. You cannot determine because they have cycle. Alright, so I want to see my time. Actually, it's not good. It's good because yeah. So okay, waste a lot of time to figure out that. Okay, we can just brute force it. Brute force it. Brute force it because we just have any very start position, but because of the constraint, we can find our start point and do BFS. Actually, the amortized. This is amortized time complexity. It looks as a 3 for loop, but actually it's this will be linear. This will be n. This will be n because the group only have each node only in one connected component. So this will be not the n squared will be linear, and this will be the edge size. So it's good, suitable. Yeah. Too late to figure out that it can work. So okay, so let's quick demonstrate about this problem. Illustrate it. Alright, so this problem is that you need to figure out that for a group, it's actually the cognitive component, and the group, the cognitive component is that you need to find out that the cognitive component, and each cognitive component you just do label order, and actually the hardest part is that it's not easy to determine the start position because they may have many integers very small, but the good strategy is that we can find a good integrate. And actually we don't need to do this. We may just do for each start in group. Actually, this can work. This also can work. This also can work. I think this can work. Oh, okay, this cannot work. So, okay, interesting. This cannot work. Wait, what? Well, they may have cycle, but right, it doesn't matter. So, the strategy is that you find the minimum degree because the start point is always be the leaf node. You know it's a leaf node. So actually it's a leaf node, and leaf node is always have the minimum degree. So find the minimum degree and do a label order. But you need to be careful that you need to do is that we need to make cognitive component, and this part we can use unified approach. And for after we do unified, we can do the group and use BFS. And BFS is find a level, but you need to think how to find a level. And actually, impossible case is that they have two nodes that going to the same node, but they have a different distance. You need to be careful of this. If they have different distance, that means that they are not than the good. So how do we find a different distance? We can do this. If any other adjacent node, if they are already visited and they are not as adjacent group index, just -1, they may from the parent or from a child. We have 2 adjacent. So that's the idea, and this is DFS. You need to be careful that it's an impossible case, and just get the best group in for each start position. So get the best group and then summarize them. So this is problem 4. Okay, it's really interesting, and I think it's hard. Right, so about problem, okay. I think time is up. Okay, so oh my god. So, let's just diagonal. I don't want to waste time to illustrate this problem. You just do diagonal, you build a graph and you run diagonal. If you don't know diagonal, you can practice some similar problem. And actually, we just form node, and for each node, get a minimal cost and update it and find the minimal distance here. Yeah, this answer. It's problem 3, and problem 2 is that it's greedy approach, and you need to find a lot of each team should have the same size, and the total scale is maximum. Another maximum, but it's you don't need to find a maximum, but actually they only have one case can pair them. So actually you just pair one by one from the minimum and maximum, because min pair max, and that will be the best approach. So they only have one case. Actually, we cannot have another case, because if we pair these two, the 2 are decreasing. They cannot pair. So you just pair them, and yeah. So actually, this problem is that greedy and sort them and get a sum, and there's another sum. We pair the first and the last position. For example, we pair this. That's a pool pointer. 2 pair 4, 2 pair 4, and 3 pair 3. That's the answer. So it's problem 2. Pull that in and summarize it. Okay. About problem 1, it's actually just a string processing problem. And you need to just do as the problem saying is secure as the last character of a word is equal to next word first letter. So you first use string to separate the word and just get a current nest. You just compare them. That's the idea. Okay. So that's the problem.